Hey, this is Dr. B, and let's combine some equilibrium constants. Analogous to Hess's law, we can flip reactions, we can double them, we can add them, and we can apply their equilibrium constants to get the new equilibrium constant for a reaction without ever performing the reaction. Imagine that A is converted into B. Well, the K value would be, for the equilibrium, B over A, and let's say that happened to be 3. Were we to want to know the reverse reaction, we don't need to perform that reaction. It is simply A over B, and therefore it's 1/3. What did we learn? When you reverse a reaction, take the inverse. I won't show the examples for how these apply, but you kind of always go up in order of magnitude. So when you double a reaction, you don't double the K value, you square it. And when you add reactions, here A is converted to B, B is converted to C, so if we combine them, we get A plus B turns into B plus C, B cancels, and for A turning into C, we would multiply those K values, and we'd get 15. To summarize, if you reverse a reaction, invert the K values. If you double a reaction, square the K values, and if you add reactions, multiply the K values. Let's do a few examples. Given that dinitrogen tetroxide decomposes with this low K value, let's find the K value for the reverse reaction. It should be 1 over 0.212, or a little short of 5. Given that iodine and chlorine react in a 1/2 to 1/2 to 1 ratio with a K value of about 454, let's find the K value for 4 times that amount. We'll have to take that K value and put it to the 4th power, bringing it up to 10 to the 10th. And here's a long one. We have 3 reactions that you're given, and they want you to combine them in such a way that you will end up with this one. All you need to do is for each reaction, see if you need to flip it and see if you need to multiply it. For the first one, I see that N2 does not show up, so I guess it's going to cancel. O2 does show up, and it's on this side, but also this one's going to have an O2 in it. Interesting. And I have N2O, which is definitely on the wrong side. I'm going to flip this one. The fact that this is 2 and that's 2 means I will not multiply it, so I'll be writing this down fresh, reversed, and I'll take the inverse of that K value, 1 over it. And 204 is on the wrong side, and it's also not enough. For this one, I'm going to invert it, and I'm going to double it. The third one, N2, is, I think, on the right side because, look, this one got reversed, and it's over there. But it's only a quarter the value we need it to be, so I am going to not reverse it, but I will take the 4th power of it. And then I assume, based on what I'm seeing, that if I do all that and add those 3 reactions up, I'll get the 4th one. So the last step will be to multiply all 3 of the new K values. Now it's definitely a good idea to write them all down fresh and see if it works out. So that's the summary. Reverse, reverse and double, and quadruple. Therefore, here it is reversed. Take the inverse of the K value. Here it is reversed and doubled, so take 1 over K squared. And the last one needs to be multiplied by 4, so take that K value to the 4th power. Good, you got all 3 fresh ones. We're going to add them up, so for the K values, we'll multiply them all together, and we get a value of 1.1 times 10 to the 6th for the desired reaction. Equilibrium constants can be combined.